Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to begin to learn how to solve exponential equations. And in this video we're going to look at two different types. One is a little easier than the other, but they both follow the same principle. On this screen I have two exponential equations where we're going to rewrite the right-hand side in terms of the base on the left-hand side. And at that point, we can use the one-to-one principle of exponential functions. If the two functions are equal, the exponents must be equal as well. And then we'll convert it to an equation involving just the exponent. So first, we've got 4 to the x power equals 1 over 64. And I want you to notice that 64 is 4 to the third power. So 1 over 64 can be rewritten as 4 to the negative third power. Now that I have the bases the same, the only way that these two expressions can be equal is if the exponents are the same. And so we come up with an equivalent equation of x equals negative 3. And that's the solution to this equation. Part B is similar, except the exponent's not going to be negative. 625, what you want to try to do is start raising 5 to powers until you reach 625. If you go past 625, then we need to come up with another strategy. 5 to the fourth power is 625, so we can rewrite this as 5 to the x power equals 5 to the fourth power. And again, because the bases are the same, then the exponents must be the same, and we have x equals 4. We can use our solution set notation for these, just like the other equations we've learned to solve. Now, the next two examples don't go quite so, the next one does, the last one does not. We know that 9 is 3 to the second power. So here, I can leave the left side alone. 3 to the 2x minus 3 power equals 3 squared to the 3x plus 1 power. Now, a property of exponents, if you're raising x to the a power to the b power, we can simply multiply those exponents. So here, I can multiply the 2 by 3x plus 1. So we get 3 to the 2x minus 3 power equals 3 to the 6x plus 2 power. Here we know that the bases are identical, so the exponents must be the same. And our new equation is 2x minus 3 equals 6x plus 2. And so what we've done is we've changed this equation from chapter 4 into an equation from chapter 1. And it's a pretty common math technique. When you run into something that you don't know how to solve, turn it into something that you've done before. And so here, we've taken this exponential equation, converted it into a linear equation. Now we know how to solve it. I'm going to subtract 2x from both sides to get to negative 3 equals 4x plus 2. Let me continue that up above. Negative 3 equals 4x plus 2. Subtract 2 from both sides. Negative 5 equals 4x. Divide by 4, and we have our solution. X equals negative 5/4, like so. Now, you can plug that back in. This is going to be kind of challenging to work with because you're going to end up with, on the left side, for instance, let's see, 3 to the negative 11/2. So you're going to have the square root of 3 1 over the square root of 3 raised to the 11th power. The right-hand side is going to be the same thing. All right, so I mentioned that D is going to be a little more challenging, and here's the problem. I can't write 8 as a power of 4. Right? 4 to the first equals 4. If I multiply by another 4, I get to 16, and I've jumped right past 8. So I can't rewrite the right-hand side in terms of the base on the left-hand side. But I can write them both in terms of the same base because both 4 and 8 are powers of 2. So I can write the left side as 2 squared to the x plus 5 power, and I can rewrite 8 as 2 cubed. So 2 to the third power to the 2x minus 1 power. So now I've got the same base on both sides. I need to clean up the exponents though, and again, I can multiply those exponents. So on the left side, 2 times x plus 5 becomes an exponent of 2x plus 10. On the right-hand side, distribute the 3 to 2x minus 1. We get 2 to the 6x minus 3. And because the bases are identical, the exponents must be equal. And now we've got another linear equation. If we subtract 2x from both sides, we get 10 equals 4x minus 3. If we add 3 to both sides, we get 13 equals 4x. And if we divide by 4, we get x equals 13 over 4. That is the solution of this equation. In the next video, we're going to go over how to solve equations where the variable is the base, but the exponent is a fraction.